Hello everyone. Today I don't want to tell you what paging is. I want to show you what your operating system is actually doing internally step by step while it runs. Now, right now, like if you see, my system looks calm. Applications are open, things are responsive, nothing seems unusual. But inside the OS, there is constant decision making going on. Every process you run is divided into pages, typically 4 KB in size. These pages are mapped using something called as page table, which the operating system maintains for every process. The CPU does not directly use the virtual addresses. Instead, it relies on a hardware unit called memory management unit. The memory management unit takes a virtual address, consults the page table, and translates it into physical address in RAM. So we understood this part in our sessions. So if the required page is already in RAM, everything is fast and smooth. But if it is not, and that is where the real story begins. Let's start observing. Let me open a terminal like which you see on the screen, and let me write, say, a command, like say, for example, free. So this free command display amount of free and use memory in the system. So let me write free dash h. Now what you are seeing here is not just numbers. This is the direct summary of what the Linux kernel knows about the memory. Inside the kernel, memory is categorized into free pages, used pages, cached pages, buffered pages. Correct. So now here is the important part. Linux tries very hard to use available RAM, all available RAM efficiently. So even a used memory does not always mean unavailable. Cached memory can be freed quickly if needed. Now look at swap. Correct. The swap region here, the second part. Swap is not just extra memory. It is actually a backing store for pages that are currently not active. So when a swap usage increases, what is happening internally is this. The kernel identifies inactive pages using LRU like approximation or replacement algorithm. These pages are selected as candidates for eviction or removal, and their contents are written to the disk inside the swap area. So the corresponding page table entries are updated to mark them as not present, and this is paging out. Now let us move to a live view. So let me write top. Now we are watching the system continuously. Every few seconds, the kernel scheduler updates process statistics. At the same time, the memory manager is tracking which pages are being accessed frequently and which are not. So inside the CPU, there is also something called as TLB, translation look aside buffer. It catches it caches recent address translations. So when a process accesses memory, first the MMU checks the TLB. If found, translation is instant. If not, it walks the page table. And if the page is not in RAM, a page fault gets triggered. And now the OS takes control. Let us make it more visual. This is interactive process viewer. So let me see if we can execute. Now you can actually see the memory as bars, correct, towards top left. But what is happening internally while this display updates? The kernel is exposing memory stats through /proc file system. htop reads these values repeatedly. It converts raw memory pages into human readable visualization. And when the bar increases, it means more pages are being allocated in RAM. When swap starts showing activity, like if you see below, okay, it means pages are being moved out. Now let us force the system into a real situation. Okay, so let me type something here. So I'm using a command called stress or utility called stress. Now this stress is a tool to impose load on and stress test the system. Okay, utility available. Fine. So let me write stress. So what I'm going to create is I'm going to create processes that demand large chunks of memory. So how I do this? So stress PM2 and total number of bytes is 1 GB. Now what I'm doing is I'm just creating a process that demand large chunks of memory. Now what kernel would be trying to do? Kernel would be trying to allocate uh, free pages. Now let us see this. You can visualize that here. You can see the increased memory operations at the top left. If insufficient, okay, reclaim the pages from cache. And if still inefficient or insufficient, initiate the page replacement. At this point, the kernel's page reclaim mechanism kicks in. It scans memory zones and identifies active pages and inactive pages. Correct. Inactive pages become eviction candidates. Then dirty pages are returned back to the disk. Clean pages can be dropped immediately. You can see the increased memory operations happening. And this is where paging becomes unavoidable. Now let us confirm it. So let me open third terminal and let me write something here as free-h. Now you can see like here, if I continuously do this, let me add it here. Still there is no stress added that way. Okay. So let us try doing something more. So when I wrote this stress dash VM to VM number of bytes to be 1G, correct? It is like I have two worker process. Each of them is trying to access 1 GB. Now let me do one thing. Okay, I'm writing this. Let me write timeout 60 seconds. Okay, so as to prevent the system hanging. Let me see. Correct. So you can see it failed. Fine, the process has failed because I probably gave wrong option. So let me write timeout. Yeah. So let us see back that again. If I go here and if I write free-h, correct? You can see the changes happening with free, correct? Even used. There is no change right now with respect to swap, correct? Now you can see the change exactly happening. So swap is not currently in operations, correct? You can see the changes that are seen there with the two worker processes. So let me add more stress instead of this. So what I would be doing is now I would be creating 4 processes. Right? And let me check this. Now you can see my system is entering into non-responsive mode. Right? So I am pressing the keys. You can see because it already occupied 4 GB of storage. Correct. So it is not responding at all to what exactly I was expecting to see. So let me write free-h. Now you can see the earlier one and this one. Like it. Let us check the changes. Still, now you can see swap came into picture in the background. Correct? Here, swap is working around. Correct? In this picture, at least you can see with respect to this particular option. Fine. So what we experienced here, some pages are no longer in RAM. Their data is safely stored on the disk. Page table entries are updated accordingly. Now, as this particular system you must have experienced, now it entered into non-responsive mode. So automatically the sharing has been stopped. Correct. Uh, Now the CPU exactly generated the page fault interrupt. Correct. And then my OS perform these steps internally, like pause the process, look at the required page, find the frame, and so on. Correct. Ultimately, so the as the machine entered into non-responsive state, everything is happening in milliseconds. Correct. Now, if I go back and really try to again see, like if I can see whether my sharing is still on, sharing was removed automatically by the system because of the happenings there. Correct. So let me remove the pages from memory. Hopefully, let us see like what is the available. Correct. And then like once it is done, probably you would be seeing. So I stopped htop, so which you might not be able to see right now from your machine. Correct. So I stopped everything displayed over there. Fine. And let me go back and now see like if I can share back one more time. So it actually disconnected due to load on the system. So let me go back and refresh. If it can get connected, then probably we would be able to see this again. Let me go back. Let me join. Because of the swap in, swap out processes, what is happening? The system entered into too much load rather. Correct. So that's the reason why it is not showing me the response completely from the machine. Fine. So let me start again the browser. So you might be saying like probably here I have disconnected my laptop. Actually, the laptop is not disconnected. What happened was the meeting automatically got you can say terminated due to the load that has been experienced over there. Right. So let it launch the meeting, and now I will be joining from browser again. Okay. Hopefully it will permit, and then we will try to check it with the most honest tool called vmstat. If we are permitted to see that, rather let us see if we can. So I'm trying to join back again with Zoom. Yeah, so we got connected. Right again. So let me now share my screen. Let me share my screen. So now the screen is visible. Correct. Yes. So let me minimize this and let me go back here. Correct. So instead of this, what I'll be doing now is like I would be writing vmstat. Now you can see the SI is swap in and SO is swap out. So how many swap? So SO is increasing and pages are leaving RAM and SI is increasing. That means pages are coming back. Right now, as we stopped most of these things, so most of those services, they are not exactly seen there, but you can definitely try. So this is the exact moment where virtual memory becomes active. So what I showed here is disk IO activity triggered by memory pressure. Real-time page replacement decisions were made, which we experienced earlier before disconnecting. And all of this is happening continuously, dynamically, and intelligently. So when we say paging happens in the background, what we really mean is there is a constant conversation between CPU, RAM, disk, and the kernel, deciding where every piece of data should live at any given moment. So let me do it with the other terminal again. So instead of 4, I will take 3. Okay, and if like we'll check with it, we'll check here. with vmstat. You can see constantly identify values for SI and SO if they are there. Now check buffer also is changing. Correct? SI, SO, there is no change still. 936. You can see the buffer changes free, even like swapped still continuous and same. Correct. When swap comes into picture, at the ultimately swap in and swap out can be seen. Rather, the values would be changing. Right now, we are just seeing the remaining parameters. Correct. Other parameters are changing. Correct. So let me stop this and let me take it with 4 again. Then probably stress can be seen. Now you can see my machine got stuck. Correct. Because it is not responding to my command. You can see the cursor exactly got stuck there. And probably this would be like this browser which I shared browser from the browser, the meeting. What exactly will happen? The program probably might be removed from memory. Okay, and that's maybe the reason why uh, you are not able to see. My machine got stuck there. Correct. So this is the internal behavior of an operating system while it was managing memory in real time, because we are providing too much stress on the machine, and that's why it is not responding right now currently. So the screen got freezed. Correct. So despite there was huge things that are happening, and you suddenly see it got terminated. My meeting got terminated automatically from there. Correct. So you can definitely try this and work out. Okay, but make sure yourself like you are doing exactly what I was trying to show.